Imagine for a second that you aren't actually the pilot of your own life.
Yeah, which is a pretty unsettling thought.
Right, like instead you are just this highly advanced fleshy spaceship.
A fleshy spaceship, I like that.
And you've been blindly constructed and you're being navigated by these microscopic passengers. And their only goal, like their entire reason for building you in the first place, is just to keep themselves alive long enough to jump to the next ship.
It sounds like pure sci-fi.
Exactly. But welcome to the deep dive, because that slightly terrifying concept is exactly what we're getting into today.
It really is.
Our mission here is to give you those big, worldview-altering aha moments without making you slog through, a giant wall of academic jargon.
Yeah.
And today, we are unpacking one of the most influential and I think widely misunderstood science books ever published.
Oh, definitely.
Richard Dawkins' 1976 classic, The Selfish Gene.
Which is, it's a book that fundamentally shifted the ground in evolutionary biology. But the barrier to entry with this text is just notoriously high. And it starts before you even open the cover, honestly. The title itself has been creating confusion for, almost 50 years now?
Because the moment you hear The Selfish Gene, your immediate assumption is that it's a book about human nature.
Right.
It sounds like this cynical argument that human beings are just inherently greedy. Like we are biologically hardwired to be selfish jerks to each other.
Which is a complete misreading of the text. The book does not argue that humans are naturally selfish.
Okay.
And it certainly doesn't argue that genes possess, consciousness or malice or some sort of moral compass.
So they aren't actually selfish then?
No, not at all. A gene is a microscopic strip of DNA. It's just a molecule. It doesn't plot its next move. It doesn't have a long-term strategy. And it definitely doesn't harbor selfish intentions.
So, using the word selfish is just a terrible branding choice, isn't it?
Well, Dawkins himself has actually gone back and forth on that over the years.
Because if a gene has no intentions, calling it selfish is kind of like calling a winning lottery ticket ambitious.
That is a great way to put it, actually.
Right. Like the lottery ticket didn't scheme to be drawn. It didn't outsmart the other tickets in the drum. It just happened to possess the exact right sequence of numbers to survive that drawing process.
Exactly. The lottery ticket is just a piece of paper that made it through the filter. And by removing all the human emotion and the moral baggage from the word selfish, we can finally see the cold, mechanical reality of survival.
Which is what?
Well, selfish simply means that genes that are better at replicating themselves will inevitably become more common over successive generations.
Because there are just more of them.
Right. Natural selection is really just a filter. It favors molecules that are successful at making copies of themselves.
But that tiny shift in perspective, saying the gene is the thing trying to survive, that turns traditional biology completely upside down, doesn't it?
Oh, absolutely.
Because before this, you'd always hear phrases like survival of the species. The idea was always that evolution was driven by what was best for the group, or, at least best for the individual animal.
Right, but Dawkins argued that the true beneficiary of evolution is not the species. And it's not even the individual organism.
Because the individual doesn't last.
Exactly. The individual is temporary. The individual dies. The true beneficiary, the thing that actually gets passed down and survives across millions of years, is the genetic code itself.
The code lives on.
Yeah, the gene is the fundamental unit of selection.
Which brings us right back to that fleshy spaceship analogy. Because if the genes are the winning lottery tickets, and they are the things that actually survive, what are we?
We're just the vehicles.
Right. The book introduces this term, survival machines.
Yes.
It frames plants, animals, humans, like literally every living thing you see outside your window as temporary machinery. Machinery built by genes to protect themselves from a hostile world.
Because the environment out there is incredibly dangerous for a fragile molecule.
I bet.
So over billions of years, these molecules essentially built increasingly complex armor. And if you look at it this way, it completely changes our understanding of basic biology.
Give me an example.
Well, why did eyes evolve?
So we can see.
Right. From the organism's perspective, they evolved so we can see. But from the gene-centered view, eyes are just sensory input devices for the survival machine.
Oh, wow. Yeah.
They detect predators and food, which keeps the machine functioning, which ultimately keeps the genetic cargo safe.
So the same goes for wings or claws or legs. They're just like mobility upgrades for the spaceship.
Exactly. Upgrades to help it escape danger or acquire fuel.
But I think the most fascinating part of this whole machinery concept is how it explains the brain. Because the brain isn't just for thinking, is it? It's an onboard computer.
It's a remarkably sophisticated one, yeah. And it's necessitated by a problem of timing.
What do you mean?
Well, genes operate on an incredibly slow timeline. It takes entire generations for a genetic mutation to spread. But the environment the survival machine is navigating, that changes by the millisecond.
Right, like if a predator leaps out of the bushes.
Or a branch snaps, the genes cannot react to that in real time.
Yeah, they can't just send a little chemical signal saying, hey, duck, because the machine would be eaten before the signal even arrived.
Right, exactly. So the genes build a brain. They pre-program it with basic instincts like pain is bad, sweet food is good, and then they essentially hand over the controls.
Like putting the ship on autopilot.
Basically, the brain becomes an autonomous prediction engine. It makes split-second decisions to keep the machine alive, all in service of eventually passing those original genetic programmers on to the next generation.
It's wild to think about.
It is. It's not about achieving some sort of biological perfection. It is strictly about reproductive success.
Okay, but this brings up a massive contradiction. And I honestly think it's why so many people get tripped up by the selfish metaphor.
What's that?
Well, if our genes are these ruthless, self-interested replicators, and we are just machines built to ensure their survival, why aren't we constantly at each other's throats?
The altruism question.
Right. If you look at nature, or human society for that matter, you see a ton of cooperation. You see teamwork, altruism, kindness. If the underlying code is selfish, how do you explain a bird risking its life to warn its flock about a hawk?
Yeah, that paradox is really the crux of modern evolutionary biology. How do you get cooperative behavior out of purely self-interested components?
Right. How does that happen?
Well, evolutionary biology solves this without needing to inject any moral judgments. It turns out that cooperation is often just the mathematically optimal strategy for a gene's survival.
Mathematically?
Yeah. The framework relies on two major concepts, kin selection and reciprocal altruism.
Okay, let's tackle kin selection first, because I feel like that one makes immediate mathematical sense.
Go for it.
Like, if I help my brother move a remarkably heavy couch on a Saturday morning, the old view might say I'm just being a good person. But from a genetic standpoint, my brother shares roughly 50% of my DNA. So, by ensuring his well-being, my genes are actually protecting copies of themselves that just happen to reside in a different survival machine.
That's exactly it. The gene is essentially recognizing itself in another body. From a strictly biological standpoint, behavior that benefits close relatives is highly advantageous for a so-called selfish gene.
Because it's literally helping itself.
Yes. The math holds up perfectly. You share 50% of your genes with a sibling or a child, 25% with an aunt or uncle, 12.5% with a first cousin.
So the evolutionary drive to help someone decreases precisely as the genetic distance increases.
Exactly. And this explains some of the most profound behaviors we observe in nature, like parents sacrificing everything, sometimes even their own lives, for their children.
Wow.
From the gene's perspective, the parent survival machine is older and perhaps nearing the end of its reproductive utility.
Oh, the child's machine is brand new.
Right. It carries the exact same genetic blueprint into the future. So the sacrifice isn't really a moral triumph. It's a calculated biological transfer.
That is so cold. But it makes sense. And I guess it also explains sibling rivalry, right?
Oh, completely.
Because even though they share 50% of their genes, the other 50% is competing for the exact same limited resources from the parents.
Yeah.
It's a literal genetic tug of war.
It is. But the framework extends far beyond the family tree. The second concept, reciprocal altruism, explains why we cooperate with total strangers.
Okay, so this is the classic, I'll scratch your back if you scratch mine.
Right. But the mechanics of how that evolves in nature are just fascinating. Think about vampire bats.
Okay, vampire bats.
They need a blood meal almost every night to survive. If a bat fails to find food, it will literally starve to death very, very quickly.
Oh, wow. High stakes.
Very high stakes. But researchers noticed something incredible. Bats who successfully fed will actually regurgitate blood to feed a roost mate who went hungry, even if they aren't related.
Which sounds completely contradictory to the idea of a selfish gene. Why would you give away your hard-earned calories to a total stranger?
Because the bats have long memories, and they live in stable social groups. The bat that goes hungry today might be the one who finds food tomorrow.
Ah, okay.
So by sharing today at a relatively low cost to itself, the successful bat is basically buying an insurance policy against future starvation.
That's amazing.
Yeah, and over time, groups of bats that cooperate survive much longer than groups of entirely selfish bats.
But for that system to work, The survival machines have to be able to detect cheaters, don't they?
They do.
Like if there's a bat who always takes blood but never gives it back, the whole system just collapses.
Which is exactly why reciprocal altruism is usually found in species with highly developed brains. You need to be able to recognize individuals, remember past interactions, and feel things like trust or resentment.
Oh, that makes so much sense.
Right. In humans, this evolutionary mechanism likely laid the groundwork for our complex emotions regarding fairness, gratitude, and guilt.
So being a good neighbor actually has a deep biological payoff.
It does.
But we have to draw a hard line here, I think, because this is where a lot of social theories go completely off the rails.
Yes, this is a very important distinction.
Explaining why a behavior exists biologically is not the same as justifying it morally.
Exactly.
Just because biology explains why we favor our family members or why conflict exists, that doesn't mean that's how we should organize our modern societies.
That's the is-ought fallacy. Just because something is a certain way in nature doesn't mean it ought to be that way in human society. We are investigating the mechanical origins of behavior here. We're not consulting a moral guidebook. The genes are blind.
And that blindness, honestly, is the hardest part to wrap your head around.
It really is counterintuitive.
Because when you look at how intricate this all is, like the mathematics of kin selection, the cheater detection required for altruism, or just the physical complexity of an eye, it looks incredibly deliberate.
It looks planned.
Yeah. It looks engineered. How does a blind process with no foresight build something that complex?
It's the illusion of design, and it's driven entirely by the pairing of random mutation and non-random selection.
Okay, break that down for me.
Imagine DNA copying itself as someone typing out a million-page manuscript over and over and over. Occasionally there's a typo, a random mutation.
Okay.
Most of those typos make the instructions worse, and that survival machine fails. It dies out, taking the typo with it.
But every once in a while, the typo actually improves the sentence.
Exactly. It makes a bone slightly denser or a retinal cell slightly more sensitive to light.
And because that specific machine is now slightly better at surviving and reproducing in its specific environment, that typo, that beneficial mutation, gets passed on.
Right, it gets locked in. And when you run that cycle of random error and harsh environmental filtering over billions of years, it creates structures of breathtaking complexity, structures that appear to be consciously engineered.
But there is no architect.
No architect.
It's just billions of years of trial and error.
Exactly.
Which brings us to a massive pivot in the material. And honestly, one of the most unexpected twists in the whole book. Because this blind mechanical process of replication, mutation, and selection, well, it isn't limited to biology, is it?
No, it's not.
It isn't just about DNA.
Right. And this is where Dawkins makes a leap that really secured the book's place in cultural history. He realized that the rules of natural selection apply to anything that replicates.
Anything.
Anything. Any information that copies itself is subject to these exact same forces.
And to describe this, he invented a word you probably used like 5 times before breakfast today.
Probably more than 5.
He coined the word meme.
Yes. Long before the internet, long before social media, the term meme was created to describe a unit of cultural transmission.
Because when we say meme today, we think of a funny picture with text on it spreading on Twitter or Instagram. But the original scientific definition is so much deeper than that.
Oh, vastly deeper. A meme is an idea, a fashion trend, a catchy melody, a religious belief, or even a specific way of building a tool.
Right. Just as biological genes replicate by jumping from body to body via sperm and egg, memes replicate by jumping from brain to brain via imitation.
Exactly.
So a catchy pop song like an earworm is literally a cultural virus.
Yes.
It infects my brain. I start humming it. You hear me humming it, and now it's in your brain. It just replicated.
And just like genes, memes are subject to mutation and selection. If a meme is useful or emotionally resonant or just psychologically sticky, it spreads, it survives.
And if it's not?
If an idea is boring or overly complex, it fails to replicate and it dies out. Think about how a rumor mutates as it spreads through a high school.
Oh, that's a perfect example. The juicy parts get exaggerated because they are better at grabbing attention, and the boring details get dropped.
Right. The rumor evolves to become more contagious.
So cultural evolution operates on the same raw mechanics as biological evolution, but just at a vastly accelerated pace.
Vastly. A genetic change takes thousands of years. A mimetic change can sweep the globe in a matter of days. Ideas compete for the limited real estate of human attention, just like animals compete for limited resources in a forest.
Okay, so we are dealing with some incredibly heavy, worldview-altering material here.
We really are.
We're talking about humans as fleshy spaceships, genes as blind programmers, the math of altruism, cultural viruses rewriting our brains.
Yeah.
When we look at how people actually consume this information today, especially as like a 15-hour audiobook, how does that experience hold up?
It's a very polarizing experience, to be honest, and it highlights the difference between listening to science and reading it.
Okay.
The consensus on the audio format is that the conceptual shifts, like the stories about animal behavior, the broad philosophical implications of the survival machine, those are incredibly gripping to listen to. Dawkins is a masterful storyteller when it comes to the natural world.
Right.
But this is a book fundamentally rooted in the mathematics of evolution. There are entire sections dedicated to the granular mechanics of kin selection, breaking down the exact probability of gene sharing across distant relatives.
Yeah, that sounds rough on audio.
When the arguments get that dense, an audiobook can become a liability. You can't easily pause, stare at a paragraph, trace the logic backward, and ensure you've grasped the underlying math.
It's the difference between listening to a lecture and studying a textbook. If you just want the paradigm shift, audio is great. If you want to understand the exact mathematical proof of reciprocal altruism, you might need the physical page.
Exactly. And that leads into a broader piece of context that is essential for anyone diving into this material today. We have to report impartially on where this book actually sits in modern science.
Right, because it was published in 1976.
Yes, it was revolutionary, and the gene-centered view remains a massive foundational pillar of evolutionary biology.
But it is not the undisputed law of the land anymore.
No, it is heavily debated. The biological sciences have advanced rapidly over the last half-century. For instance, there is an ongoing, really fierce debate about multi-level selection.
What does that mean?
Well, it challenges the idea that the gene is the only level of selection. Some evolutionary biologists argue that selection can happen at the level of the group.
Oh,
So if you have a group of highly cooperative humans, they might outcompete and survive better than a group of selfish individuals, meaning the group itself is the unit being selected by nature, overriding the selfishness of individual genes.
And then you also have things like epigenetics, which completely complicates the picture, right?
Oh, absolutely.
Because we now know that the environment you live in, like your stress levels, your diet, can actually change how your genes are expressed.
Huh.
And you can pass those changes down to your kids.
Which is wild.
Yeah. The genes aren't just this unchangeable blueprint locked in a vault. They're actively interacting with the outside world.
Exactly. The gene-centered view is a lens. It is an incredibly powerful, clarifying lens that explains a vast array of natural phenomena. But it is not the only lens through which modern science views life.
So if you were on the fence about tackling this material, knowing that parts of it are mathematically dense, and knowing that the science has continued to evolve since the 70s, what is the ultimate takeaway? Why spend the time?
Because it forces a fundamental rewiring of how you perceive existence.
That's a big claim.
It is, but even if the scientific edges have been sanded down or expanded upon, understanding the mechanics of a self-replicating universe is profound. It strips away the magical thinking about why animals and humans behave the way they do, and replaces it with a cold yet awe-inspiring mechanical reality.
It gives you the blueprint of how life boots itself up from simple chemistry to complex society.
Exactly, as long as we remember that it's a blueprint of our past, not a roadmap for our future.
A crucial final reminder. It is an explanation of biological mechanisms. It is not an endorsement of selfishness. And it does not dictate how a conscious society must operate.
Perfectly said.
And that is exactly what we set out to extract today. We've decoded the misleading branding of the selfish metaphor and seen the actual blind process of natural selection.
We have.
We've explored our rather humbling status as heavily armored survival machines built by microscopic lottery tickets, just trying to stay in the game.
And we examined how those same blind, calculating molecules manage to invent cooperation, building family bonds and societal trust purely out of a mathematical necessity to survive.
And we trace that exact same survival logic into the realm of human culture. Discovered that the memes shaping our thoughts, our music, and our religions are just another form of life, fighting for space in our minds.
It really changes the way you look at a bird, a family member, and even the thoughts bouncing around in your own head.
It really does. But before we close out this deep dive, consider this. If our physical bodies, our instincts, and our deeply held drives are fundamentally shaped by genes blindly trying to survive,
Right.
and if our cultural thoughts, our trends, and our ideas are fundamentally shaped by means blindly trying to survive,
Right.
where exactly does our own conscious, independent free will fit into the driver's seat of this survival machine?
Man, that is the ultimate question, isn't it?
It really is. Thank you for joining us on this deep dive. Keep asking those big questions and keep exploring the world around you.